discussing about the definition of thermodynamics, what actually is meant by thermodynamics. So we have discussed that thermodynamics actually is a combination of two words. One is therm, second is dynamics. Therm means heat and dynamics means power. So wherever there is heat to power conversion or power to heat conversion is involved, so it means we are discussing about the principles of thermodynamics, right? So it's not just heat and power, because whenever there is a heat transfer or whenever there is a power transfer, something normally changes within the system. For example, when heat is transferred to a substance, its temperature will rise. Similarly, when heat is extracted from a substance, its temperature will drop. So there is a heat transfer, but due to this heat transfer, there is another change, and that change is temperature. So thermodynamics is dealing with heat, work or power, and the properties of the system. Because of this heat and work interaction, properties of the system also changes. So some commonly used properties are temperature, pressure, volume, and there are many other properties which we will learn during the course of this course of thermodynamics, right? Okay, so here I think we have covered these points. Now let's see what is the next point. It is again describing the thermodynamics. We study in thermodynamics, what we do, we study the effects on different substances as we may expose a mass to heating or cooling or to volumetric compression or expansion. So I will explain it with the help of a practical example. So in thermodynamics, what we are doing, in every thermodynamic device, there is some working substance involved. For example, in air compressor, the working substance is air. And what we are doing in a compressor, we are trying to compress this air, right? So, okay, let me show it. So for example, there is a compressor and we are supplying electrical energy to this compressor. Electrical energy, I am saying it is a form of power, not heat, right? Flow of electrons, there is some movement of something which we can see or we cannot see, but at least there is a movement. So then it is some work is supplied to this compressor, and what this compressor is doing, it is compressing some substance from initial point 1 to final point 2. During this compression process, what has happened? Its pressure is raised from P1 to P2. So during this process, we have compressed, here the term compression, we have compressed a working substance, right? So we have compressed a working substance inside a compressor. If it is a turbine, for example, now let's take the example of a turbine. So let me show it. For example, this is turbine. In turbine, the reverse is happening, the reverse of compressor. Some fluid is entering at some initial high pressure, and what you get some work output. In case of compressor, we were supplying work, but in case of turbine, we get some useful work output or power output. And some substance, which was here at point 1, now it will leave at another point 2. Inside the turbine, the substance was entering at a higher pressure P1. Now it leaves at a lower pressure P2. Why pressure is dropped? Because some energy is taken out of that substance in the form of work. So in this process, pressure is dropped. Pressure is dropped means there is expansion. Something has expanded, volume is increased. That's why its pressure is dropped. So again, you have some working substance. For example, here it was steam, if it is a steam turbine, right? Here it was air, if it was air compressor. So you see, in both of these devices, we are using some kind of substance. Here, what is written, we study the effects on different substances, and that substance may be heated, cooled, compressed, or expanded. So we have seen two examples of compression and expansion. Now, heating and cooling, what is happening in your air conditioner? So in case of air conditioner, for example, this is an air conditioner or refrigerator. This is your room air, which strikes the surface of this air conditioner. It was at high temperature initially, for example, 30 degrees Celsius. Now, when it strikes this cold surface of your air conditioner, it will leave at a lower temperature, for example, 20 degrees Celsius. So during this process, what has happened? Cooling. So again, inside the air conditioner, there is a working substance which is absorbing the heat of this air. So you normally know whenever you see that your air conditioner is not working, so normally you say that gas is leaked. Probably the gas of the air conditioner is not there, right? It has been leaked. So you have to fill your air conditioner with that gas. So we will learn the working principle of air conditioner or refrigerator later on. But here, just I want to say that what was this working substance doing? It was absorbing the heat of this air. That's why this air was cooled from 30 to 20 degrees Celsius. So what was happening to this substance? It was getting heated up because it was taking the heat of the air out. So here the substance was heating up, right? At the same time, in some other application, your substance may be cooled down, right? So in any thermodynamic device, either there is a heating of a substance or cooling of a substance, or you are compressing a substance, or you are expanding a substance, right? So in any thermodynamic device, either one of these four processes are occurring, or combination of these four processes are occurring: heating, cooling, compression, or expansion, or combination of these four. In some devices, your AC, it has two components. One is inside unit and one is the outside unit. Inside unit is getting heated up because it is absorbing the heat from the room air. But at the same time, it has an outside unit where it rejects the heat to the ambient. So there it was cooling. Your substance, this working substance of your air conditioner or refrigerator, is absorbing heat from the room air or the refrigerator cabin air, and then it is rejecting heat to the ambient air. So on one side, there is the heating of this substance. On the other side, there is cooling of the substance because it is rejecting heat to the outside ambient air. So these are, for example, these three practical examples you have seen. In all these three examples, there is some mass of substance involved. Here it was air, here it was steam, here it was refrigerant gas, this one. There are two substances, one on the air side, one on the air conditioner side. Okay. So during all these processes, what we are doing, either heating, cooling, compression, or expansion, or either we are compressing or expanding. So in all these processes, when you were compressing this gas, what was happening to pressure? Pressure was increased. Temperature was also increased. The reverse phenomena was occurring here in case of turbine because we were extracting energy out of this fluid. So its fluid pressure was dropping. When pressure drops, its temperature also drops. Similarly, here in case of air conditioner, we were heating this refrigerant gas. Similarly, you may be cooling that refrigerant gas. So whenever there is heating, cooling, compression, or expansion, there will be changes in temperature, pressure, or volume. So that is what we will try to learn in thermodynamics. In every thermodynamic device, these are the four processes are occurring, and due to these four processes, either temperature, pressure, or volume changes. So this slide just describes what exactly thermodynamics is all about, right? It is a study, or it is a science which deals with the energy conversion processes. Here you see there is energy conversion. This energy, electrical energy, which you have supplied to the compressor, is converted into the fluid energy, energy of the fluid. Energy of the fluid means the pressure of the fluid is increased. So this energy is transferred into another energy. Similarly, here, the energy of the fluid, which was flowing through this turbine, is now converted into work. right? So this form of energy is converted into another form of energy.
Sir, excuse me.
So in all these devices, जी, any question?
सर ये जो गैस हीटर, सर जो ये गैस हीटर होते हैं सर,
जी पूछें।
हेलो सर, आवाज आ रही है सर?
जी जी बोले। जी आ रही है आवाज।
सर जो गैस हीटर होते हैं सर, सर उसमें भी थर्मोडायनामिक का प्रोसेस होता है ना?
बिल्कुल, उसमें भी थर्मोडायनामिक
उसमें भी थर्मोडायनामिक। तो सर उसमें कंप्रेशन होती है या उसमें एक्सपेंशन होती है, कंप्रेशन होता है सर?
नहीं, उसमें बर्निंग हो रही है, उसमें हीटिंग हो रही है। आप क्या कर रहे हैं? हीटिंग कर रहे हैं। वो जो केमिकल एनर्जी ऑफ द फ्लूइड है, इट इज कन्वर्टेड इनटू हीट, राइट, एंड दैट हीट इज यूज्ड टू डू समथिंग। ठीक है, अपना माइक ऑफ करते हैं अगर आपने। ठीक है, सो जो प्रोसेस जो फिनोमेना आपके गैस हीटर में हो रहे हैं, दैट इज ओनली हीटिंग, राइट। Although there is some pressure is involved, because you give some pressure to this gas so that it can flow into the house or into the building or into the whole society where you are supplying gas. So there is some pressure at the back of this gas, but right in your heater, what is happening is that the chemical energy of the fluid is converted into heat, and this heat is then transferred to some other substance for cooking or for other things. So it is the main phenomena which is occurring there is heat, not compression or expansion. Okay. So this was just the basic of thermodynamics. Let's move on. Now here you see another practical device of a practical thermodynamic device. Actually a complete system. Device is a very small word. Here I would say it is a complete system. So what is that system? It is actually a diagram of a steam power plant, right? You see a schematic diagram of a complete steam power plant. Okay. So I will explain this to you, the working principle or the basic working of that steam power plant. Actually, it is a topic of thermodynamics too, actually. There is a complete chapter of steam power plant. So here you just see a simple schematic of a steam power plant. This is an example of a practical thermodynamic system. At this stage, you will not be able to fully understand the thermodynamics of this power plant because it is a topic of thermodynamics too, but at least you will have some idea about the working principle of this practical system. The purpose of showing this power plant at this stage is that it will help us to understand various basic concepts of thermodynamics, which we will study in the coming chapters, because now we are studying thermodynamics 1, and thermodynamics 1 is just the fundamental concepts on the basis of which we will be able to design more complex systems in thermodynamics 2. So I shall be using this practical example in every lecture, in every coming lectures in the next few weeks. And with the help of this practical application, we shall try to understand the fundamental concepts of thermodynamics. So now let me explain the working principle of this typical steam.
सर आपकी आवाज कट रही है।
Okay. जी, अब आ रही है आपकी आवाज? हेलो।
यस सर, आ रही है।
जी सर आ रही है सर। सर कट रही है।
बस फिर थोड़ा सा इशू होगा आपके इंटरनेट कनेक्शन में।
सर मेरी भी कट रही है।
ओके। सो मेरे पास इस वक्त कोई सोल्यूशन नहीं है इस चीज़ का, बस जो इंटरनेट कनेक्शन है बस इसी पे ही गुजारा करना है। एनीवेज ये लेक्चर रिकॉर्ड भी हो रहा है, तो लेटर ऑन मैं इसकी रिकॉर्डिंग भी आपके साथ शेयर कर सकता हूँ। तो अभी अगर आपको कुछ नहीं समझ आ रही बिकॉज ऑफ वॉइस कि वॉइस कट हो रही है, तो बाद में आप इसकी रिकॉर्डिंग भी देख सकते हैं। और इन एनी केस हमारी जब फेस टू फेस क्लासेस स्टार्ट होंगी तो इसमें से कुछ ना कुछ टॉपिक्स दोबारा रिपीट हो जाएंगे, सो वो कोई इशू नहीं है। ठीक है, तो अभी चूंकि अब मजबूरी है और हमारे पास कोई ऑप्शन नहीं है, इसी तरह चलना है इस सिचुएशन में, तो बस इसी तरह गुजारा करना है। हाँ, अगर बहुत ज़्यादा इशू है, बिल्कुल आवाज़ नहीं आ रही, तो फिर मुझे बताएं चैट में।
सर एक वर्ड आता है, एक वर्ड चला जाता है।
ओके, तो कोई सजेशन, कोई यहाँ पे आईटी का एक्सपर्ट?
सर ये
सर
अपलोड
होता तो एक
साथ
इलेक्ट्रिक
साथ
सही है,
अपलोड
लेकिन सर आप
करेंगे ना
रिकॉर्डेड
क्लासरूम
लेक्चर
पे।
भेजते तो सही हो जाएगा।
जी जी, एक वक्त में एक बोले जी। हमजा, आपने क्या कहा है?
सर ये आप साथ साथ क्लासरूम में अपलोड करते जाएंगे ना, सर आपने कहा है कि रिकॉर्डेड हो रहे हैं लेक्चर्स।
ठीक है, रिकॉर्डेड लेक्चर्स भी मैं अपलोड कर दूंगा।
ठीक है सर।
ठीक है जी, हम कंटिन्यू करते हैं। तो ओके, सो हियर इज दैट एग्जांपल। ओके, मैं माइक बिल्कुल अपने करीब कर लेता हूँ ताकि आवाज आपको क्लियर आए। So the purpose of this system is just to understand the various thermodynamics, basic thermodynamics concepts, which we will study in the coming lectures. ठीक है? The purpose is not to fully understand the working principle of this steam power plant. ये purpose नहीं है इस वक्त। इस वक्त purpose सिर्फ ये है कि इसकी help से हम thermodynamics के basic concepts पढ़ेंगे। But anyways, I will try to explain the working principle of this steam power plant. So let's start. मुझे यहाँ पे draw भी करना पड़ेगा. Okay. So here you see, let's start from here. So here what you see, some oil or coal or any other fuel you can burn here. So here some fuel is getting burnt in this place. So when this fuel is getting burnt here, so what is happening? Its chemical energy is converted into heat. And now this heat is transferred to this water, which was initially liquid water. Now, after absorbing this heat, a huge amount of heat, which is supplied here, it is now converted into steam, right? So this steam is now used. Now the exhaust gases are leaving here because after burning, there are exhaust. These gases are leaving from this here into the ambient, right? Fuel is burned, its heat energy is transferred, but the remaining mass in the form of ashes or in the form of smoke, it is leaving here from this side, or the solid particles are leaving from the bottom side. Okay. And now what has happened here, this chemical energy is converted into heat, and this heat is transferred to this steam. Initially, it was liquid water. So liquid water is converted into steam. Now this steam is flowing towards the next component. What is this component? That is a turbine. So inside a turbine, what you see, there is one long shaft. Over this shaft, there are blades, right? This is just a schematic diagram. It is not the actual pictorial diagram. It is just the schematic. So this high pressure, high temperature steam will strike these blades. So what will happen? It will transfer its energy to these blades, these moving blades, and these moving blades are attached to this shaft. So the end result will be that this shaft will start to rotate, right? And this shaft is rotating. This shaft is further connected to a generator. So inside a generator, now you have this combination of conductor and magnetic field. Now this shaft is actually connected to a conductor, and this conductor is actually moving inside magnetic field, and electrical energy is produced. So now what will happen to this steam? Now this steam, which was at very high temperature and high pressure here, it will now leave with a low pressure and low temperature because energy is extracted from this steam and it is transferred to this shaft here. Now this steam which has left this turbine, now this steam has low energy, but GG, koi issue? Okay. So now this steam which is here at this point, it is still at some high temperature, although its
सर
temperature is dropped.
एक्सक्यूज मी
GG,
सर
GG.
सर ये जो टरबाइन है
Mm-hmm.
सर इसमें जब ये स्टीम आती है तो ये मूव कैसे करेगा, ये मुझे समझ नहीं लगी। स्टीम कैसे मूव करा रही है इस टरबाइन को?
स्टीम के अंदर एक ह्यूज अमाउंट ऑफ एनर्जी है। वो एनर्जी कहाँ से आई थी? फ्रॉम दिस, by burning of this oil and fuel. ठीक है, by burning
जी
of
सर।
this fuel, this energy is transferred to this steam. Now here the pressure will rise. It is a very high pressure steam. So this high pressure steam, because at the exit of turbine you have a very low pressure. So from high pressure to low pressure, steam will automatically start to flow, right? because of this pressure difference. Here you have a very high pressure. Here at the exit of turbine, you maintain a very low pressure. So that's why steam moves. Okay, the purpose of this, I'm again repeating, the purpose of this slide is not to fully understand the working principle of steam power plant. That is not possible. Okay, that is the thermodynamics too. Here we just want to have a brief idea so that I can use this example to understand various thermodynamic concepts. Okay? Here you will have a lot of questions, okay, which cannot be answered at this stage. You may note those points and we shall discuss later on, or in thermodynamics too there is a complete chapter. अब इसका पर्पस क्या है वो मैं आपको समझा, एक दफा मुझे कंप्लीट कर देने दे, फिर देन यू मे आस्क क्वेश्चंस. ओके, अब ये जो जितना फिनोमेना अभी तक मैंने आपको डिस्क्राइब किया है फ्रॉम स्टार्टिंग फ्रॉम हियर एंड टिल हियर, आई विल शो इट ऑन a diagram. Which diagram? On a graph, temperature versus heat graph. So let me draw it on temperature versus heat graph. So for example, here you have X and Y axis. On Y axis, you have temperature. On X axis, you have heat or Q. Initially, here you had liquid water. So I will draw the temperature and heat diagram of water, because the working substance in any thermodynamic system, there is some working substance. So what is the working substance of this power plant is actually water, which is converted into steam. This is not the working. Coal and oil, those are fuels. Those are not working substance. Those are just giving energy to the working substance, which is liquid water. So initially, for example, you had liquid water at 20 degrees Celsius. Here in this steam drum, initially it was all liquid water at 20 degrees Celsius. And for example, assume initially this was T1, 20 degrees Celsius. Initially, the pressure in this drum was maintained at, for example, I'm just taking an example, 10 bars. Atmospheric pressure is 1 bar. But here in steam power plants, we create steam or we generate steam at very high pressure. I'm taking a typical example of 10 bars. So initially at 20 degrees Celsius, that is initial temperature T1 and initial pressure 10 bars. Now heat is supplied to this steam. So what will happen to this water, which was initially liquid? Its temperature will start to rise. Sorry. Like this one, because you are supplying heat. On x-axis, there is Q. This Q is transferred from this fuel. By burning this fuel, heat is generated, and that heat is transferred to this water until, for example, it starts to boil now. At this temperature, it will start to boil. What is the boiling point of water? Anyone?
100
degrees centigrade.
centigrade.
Celsius.
100 degrees centigrade.
Okay. So unfortunately, this simple answer is wrong, right? The boiling point of water is 100 degrees Celsius, but at 1 bar or at 1 atmospheric pressure, right? So you would have learned somewhere in physics that as the pressure increases, the boiling point also increases. So if the pressure here in this steam turbine, if this pressure would have been 1 bar, then yes, you are right, it will start to boil at 100 degrees. Then this temperature would have been 100 degrees Celsius. But here pressure is much higher. So as the pressure increases, temperature also increases. This is something which we will learn in chapter 3 of thermodynamics, this pressure temperature relationship of any substance, why the boiling point increases with pressure. This is in chapter 3. Okay, so remember, throughout in this course of thermodynamics 1, I will keep on using these terms that we shall see, we will learn, we will discuss later on, or we shall see in the next chapter, or we shall see, or we will discuss in next few slides, because everything is linked with something which we will learn later on. ठीक है, this is throughout thermodynamics 1 में ये ऐसे ही चलेगा. So ये ना समझे कि इस वक्त मैं आंसर देना नहीं चाह रहा या आंसर मुझे नहीं आ रहा. Actually, this is something which we will learn later on. ठीक है, throughout this thermodynamics 2 में ये reverse हो जाएगा. Thermodynamics 2 में I will keep on saying to you that we have already learned, we have already studied in Thermo 1, in chapter this. So this terminology will suddenly change in thermodynamics 2 because we will have covered all those basic concepts. Okay. So for the time being, just remember that as the pressure rises, temperature also rises. So initial temperature was 20 degrees Celsius. Here at 10 bar, it will not be 100 degrees Celsius. It will be much higher than 100 degrees Celsius. So we have to see from the table that at 10 bar, what is the boiling temperature? For example, this boiling temperature is 200 degrees Celsius. Water will start to boil at 200 degrees Celsius because pressure is very high. You have maintained a very high pressure of 10 bar. Now, if you further supply heat at this point, from this point onwards, if we further supply heat, what will happen? Will the temperature rise? Initial temperature was 20 and
No,
you
sir,
have
एकदम
supplied
नहीं
heat.
होगा.
अच्छा, 200 डिग्री सेल्सियस पे अगर हम हीट सप्लाई करेंगे और वाटर बॉयल कर रहा है तो अब क्या होगा? टेम्परेचर राइज नहीं होगा या होगा?
सर जो स्टीम की एनर्जी है सर वो इंक्रीज करने लग जाएगी.
सर टेम्परेचर राइज नहीं होगा.
अच्छा, ठीक है, यू आर राइट, टेम्परेचर विल नॉट राइज. सो व्हाट विल हैपन? हीट तो आप स्टिल सप्लाई कर रहे हैं.
सर
राइज हो जाएगा सर.
सर वो एनर्जी इंक्रीज होगी स्टीम की.
इसके इंटरनल स्टीम की एनर्जी इंक्रीज हो जाएगी सर.
स्टीम की इंटरनल एनर्जी
स्टीम में कन्वर्ट होगा.
सर वर्क डन हो जाएगा. वर्क डन.
नहीं, मैं बताता हूँ. Okay, you have some idea, but I tell you exactly what you want to say. You are trying to say, ये अपने mics off कर लेना. What you are trying to say at 200 degrees Celsius, water will start to boil. So it means if you further supply heat, temperature will remain constant, but heat is still supplied. Heat is being supplied. So during this process, all of the liquid water is now converting into steam. So the correct way to say this is that from this point onwards, temperature will remain constant and the liquid water will start to convert into gaseous water until all the water, for example, here you had 2 kilograms of water. So until all of this 2 kilogram of water is converted into gas, your temperature will not rise. So for example, at this point, all the liquid particles which were present here are now converted into gas. Okay, now you are at this point. So at this point, temperature is still 200 degrees Celsius, but what is the difference between these 2 points? From this point till this point, all of the liquid water is converted into gaseous water or steam, right? Now here you have all steam because you are continuing to supply heat. So during this whole process, pressure was kept fixed at 10 bar. Only temperature was rising. Initially, temperature was raised from 20 degrees Celsius to 200. Now at this point, the water starts to boil. And from this point till this point, all the water, liquid water is converted into gaseous water. And during this process, no temperature is changed. Now what will happen at this point? If I further supply heat from this point onwards, now what will happen to temperature? Will temperature rise or it will remain constant? What you say?
Sir, remain constant, sir.
Anyone else?
Constant, sir. It remains constant.
Okay.
Remain constant, sir.
Why constant? यहाँ तो constant इसलिए था कि liquid water was converting into gaseous water. जितनी भी आप heat supply कर रहे थे वो use हो रही थी phase change के लिए. Phase was changing.
सर अब उसकी इंटरनल एनर्जी इंक्रीज हो जाएगी सर.
हाँ तो वो होगी ना इंक्रीज. यहाँ से इंटरनल एनर्जी तो इस पॉइंट से इंक्रीज हो रही है. इंटरनल एनर्जी ये T1 से इंक्रीज हो रही है. इस पॉइंट से लेके इस पॉइंट तक भी ये थ्रू आउट इंटरनल एनर्जी चेंज इंक्रीज. सिर्फ इस प्रोसेस ओनली ड्यूरिंग बॉइलिंग इंटरनल एनर्जी नहीं इंक्रीज हो रही. वो तो स्टार्टिंग ये 20 डिग्री सेल्सियस से ही इंक्रीज हो रही है. Okay, so during this process, when temperature was constant, what was happening? All the liquid water was converting into gaseous water, and whatever heat you had supplied, it was used to change the phase of the fluid. Now, at this point, all the liquid is converted into gas. Now, if you supply heat further, now you have again single phase, only gas. So now if you further supply heat at this point from 200 degrees Celsius onwards, again temperature will start to rise because now you have a single phase gas. It's all gas. Here it was all liquid. And here it was liquid plus gas mixture. Sorry, ये मैं mouse को use कर रहा हूँ, इसे write करने में इसलिए इतना clear नहीं है. Okay, so here it was all liquid. Till this point, it was all liquid, only temperature was rising. From this point till this point, liquid was converting into gas. That's why temperature was constant, because all of the heat was being used to change its phase. From this point onwards, it's again all gas. So whatever heat you will supply further, it will raise its temperature. So this is the phenomena starting from here, ending here somewhere. For example, here temperature is, for example, 300 degrees Celsius, for example.
सर एक्सक्यूज मी सर.
जी जी
सर ये इसका अगर हीट देते रहेंगे तो प्रेशर नहीं इंक्रीज करेगा सर? बिल्कुल
प्रेशर इंक्रीज नहीं करेगा. प्रेशर हमने कांस्टेंट रखा हुआ है. कैसे रखा हुआ है वी शैल सी लेटर ऑन. ठीक है, अभी मैं एक्सप्लेन नहीं कर सकता. ठीक है, फॉर द टाइमिंग जस्ट रिमेंबर कि प्रेशर भी कांस्टेंट है. हमने किसी तरह ये प्रेशर कांस्टेंट रखा हुआ है. ठीक है, कैसे रखा हुआ है वी विल सी लेटर. ओके, सो फ्रॉम दिस पॉइंट टिल दिस पॉइंट, this whole process was occurring inside this steam drum. The liquid water was converted into gaseous water or steam. So now at this point, the heat is stopped. Now at this point, this high temperature, जितनी भी आपने heat supply की during this process, Q, मैं इसे show कर दूँ. So during this whole process, we have supplied heat, Q, this Q. This energy was coming from this source, either oil or coal or gas, any kind of fuel which was burned, and it was supplying this Q, and major portion of this Q is transferred to this steam, right? So this steam at this point has a huge amount of energy in it, this Q which was transferred. Now at this point, it will enter into the turbine, right? So inside the turbine, now this steam is entering at a very high temperature and a very high pressure of 10 bar. At the exit of turbine, we have very low pressure. For example, here we have pressure of only 1 bar, for example. At the exit of turbine, we have maintained a very low pressure. So that's why this high pressure steam will start to flow in this direction, because here you have very high pressure, here you have very low pressure. So this high pressure, high temperature steam, which has a huge amount of energy in it, will start to flow through this turbine. So what it will do, it will give its energy to these blades. Blades are mounted on the shaft. Now how we will represent it here on this diagram? On this diagram, now when it enters into a turbine, it loses energy and its temperature drops. Now we are going in this direction. Q is dropping. Q is going in the negative direction, because this Q, a part of this Q is converted into work. During this process, what we are getting? Work output, because shaft is rotating. So what we have done in the turbine, that this Q is converted into work. That's why its Q, its energy is dropped, right? And its pressure is dropped. Here it was 10 bar. Now here at this point, pressure is very low. For example, this pressure is only 1 bar, right? This high, due to this high pressure change and high temperature, temperature is also dropped because energy is taken out. That's why its pressure drops and temperature also drops. Now we are here at this point. At this point, it is still steam, but low pressure and low temperature steam. It ends somewhere here, a low pressure and low temperature steam. Now, if you have a huge amount of water reservoir available, then simply you, let me show you. Okay. So if you have a huge amount of water reservoir available, simply you convert this water into steam here. It does some work here, and then you may exhaust it into the ambient, and then you add more fresh water. So every time you have to add fresh water, it is converted into steam, it does some work, and then it leaves into the ambient. But if you do not have an infinite amount of water available, because the purpose of these power plants is to produce this power. For example, it is a 100 megawatt power plant. So it is producing this 100 megawatts continuously for many years. So it means when the purpose is to produce 100 megawatts continuously for many years, then you should have a huge amount, infinite amount of water available, which is continuously converting into steam, doing some work, converted into electrical energy, and then it is leaving. But if you do not have a huge amount of water available, then you want to reuse this water. So whatever you are doing next is actually to reuse this water. How you can reuse this water? Because we want this water to be again at this temperature and pressure, which was here, the initial point. So what you will do here, you will convert this water into liquid again, so that the cycle can be repeated, right? So what you do, you have this next component is a heat exchanger, where this water rejects its heat to another source. For example, here you have some cold air available or cold water available, which takes this heat, and this water will be converted back into this steam, which was at low temperature and low pressure. It will convert back into the liquid water. So let me show it here again. So this steam, which was here at the exit of turbine, it will convert back into liquid water, but at a lower pressure. Pressure during this process was 1 bar, I told you. Now pressure is 1 bar. Pressure only changes whenever there is a work transfer. Pressure does not change if there is a heat transfer, because here we were transferring heat. It was not doing any work. It was just a heat transfer. So during heat transfer process, pressure remains constant. So during this whole process from T1 to this higher pressure, higher temperature, T2, for example. So during this process, only heat was transferred. So whenever there is only heat transfer, pressure remains constant, only temperature changes. Why? We shall learn later. Here, whenever there is a work transfer, pressure also changes. Pressure drops because you have taken work out of this steam. And now there is again heat transfer. This is another heat transfer process, because you are rejecting heat. We are rejecting heat to another cold source. For example, there is cold water or cold air available, where we are rejecting this heat, and this steam is converted back into liquid water. Again, it is liquid water here. Liquid water, because your water has lost its heat to another source. Now here you have a pump. This pump will increase its pressure again from 1 bar to 10 bar. This pump will increase the pressure of this liquid water from 1 bar to 10 bar, because here you are heating this water at 10 bars. So here you have a pump. So that's how the cycle completes. Now, you will have many questions, I know, okay? Because this is not clear, not very clear. So with the passage of time, we shall learn and we shall understand why there was a need to have this process, because this process at this point is very difficult to understand, this one, why we need this process. Okay? So when we will have a face-to-face, ओके अब इसका पर्पस क्या था, ये मैंने जो आपको अब ये जो हमने इसके इस पूरी सेकेमेटिक को देखा और इसको हमने अंडरस्टैंड करने की कोशिश की है, अब इसका पर्पस क्या है, इसका पर्पस मैं आपको समझाता हूँ इस पॉइंट के ऊपर। इस पूरे सिस्टम को नाउ आई कैन शो इट इन वेरी सिंपल सेकेमेटिक। इन इस पूरे सिस्टम में देयर आर 4 मेन कंपोनेंट्स। वन वाज बॉयलर, दिस वन, दिस इज एक्चुअली अ बॉयलर इन विच वाटर इज बॉइल्ड। ठीक है, are all of you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
ठीक है। So अब इस पूरे सिस्टम को मैं सिर्फ 4 बेसिक कंपोनेंट्स हैं उस पे मैं इसे शो करता हूँ। There was a boiler जिसमें हम हीट सप्लाई कर रहे थे। We were supplying heat. Q. बॉयलर के बाद नेक्स्ट कंपोनेंट क्या था? Here it was boiler. Next component was a turbine. So I show it here. A turbine. In the turbine, what we were getting work output, WT. So this was QB, heat supplied in the boiler. And after that, this steam was moving towards turbine. In the turbine, steam loses energy in the form of work. So after the turbine, you had another component in which heat was transferred because this steam was condensed. Steam was converted back into liquid. So that is called condensation by rejecting heat. So in this process, ये जो process है यहाँ पे, this is a heat exchanger. This is called a heat exchanger or a condenser because your steam was condensed. Condensed means the steam was converted from gaseous water to liquid water, right? Next component was a pump, right? In the pump, we supply energy, electrical energy. We give electrical energy to the pump and it raises the pressure of that liquid to a high pressure. And now it goes into the boiler. So ये जो पूरा का पूरा complex system है, इसे मैंने यहाँ एक simple सी schematic में show कर दिया. So this is an example of a typical thermodynamic system, right? The purpose of this, what is the useful output of this system? The useful output is this one, this work of turbine. The purpose of making this power plant is to get this work output, this movement of the shaft. जी जी
ये लास्ट वाला पंप का बता दें एक बार सर, ये इलेक्ट्रिकल एनर्जी प्रोवाइड करते हैं, प्रेशर इंक्रीज करते हैं।
देखें यहाँ जो पंप था ना, पंप का पर्पस था इसका प्रेशर राइज करना फ्रॉम 1 bar to 10 bar and it was all liquid because here in this process your steam was converted. Here it was steam, low pressure, low temperature steam, which was converted to into water again, liquid water. Here it was gaseous water, here it was liquid water, but at low pressure. Here pressure was low. What was the pressure? 1 bar, right? And now we want to increase this pressure to 10 bar because we are producing steam at 10 bar. This is 10 bar. This is also 10 bar. During boiling process, pressure remains constant at 10 bar. This pressure drops in the turbine from 10 bar to 1 bar. And during this process, only heat is transferred. Pressure remains constant, 1 bar to 1 bar. Here it is also 1 bar, right? Because only heat is transferred. There is no work transferred during this condensation process. During condensation process, only steam in gaseous form is converted into steam in liquid form at the same low pressure. Temperature will also drop. Okay, I told you earlier, this is still a difficult thing to understand or explain at this stage, right? Now, I was telling you the purpose was that now we have an example. Okay, अब last slide में हमने क्या पढ़ा था कि thermodynamics deals with heat, work, and बताएं, what was the third thing?
सर वॉइस की प्रॉब्लम आ रही है।
किसकी प्रॉब्लम आ रही है?
प्रॉपर्टीज ऑफ सिस्टम।
प्रॉपर्टीज ऑफ सिस्टम। अब आप देखें इस सिस्टम में, इस पूरे thermodynamic system में there is heat transfer, QB, there is heat transfer, QC, there is work transfer, WT, work of turbine, and there is work transfer, work into the system, पंप में जो वर्क दे रहे हैं, ठीक है। एंड प्रॉपर्टीज ऑफ सिस्टम आप देखें, ये 1 bar से 10 bar प्रेशराइज हो रहा है। यहाँ टेम्परेचर फॉर एग्जाम्पल 20 डिग्री सेल्सियस था, यहाँ पंप में टेम्परेचर नहीं चेंज होता है, पंप में सिर्फ प्रेशराइज होता है। आपने एक्चुअली घर में भी देखा होगा, पंप में फ्रॉम इनलेट टू एग्जिट टेम्परेचर नहीं चेंज होता है, उसका प्रेशर राइज होता है। तो यहाँ सिर्फ प्रेशर राइज था। बॉयलर में क्या हो रहा था? टेम्परेचर वाज इंक्रीज फ्रॉम 20 डिग्रीज टू 300 डिग्री सेल्सियस, राइट? So you see, this is a thermodynamic system. This is a thermodynamic system in which there are work transfers, WP and WT. There are heat transfer, QB and QC, and there are changes in properties. There are properties of the system which are keep on changing during every process. Now, in this system, there are 4 thermodynamic processes: pumping, boiling.
आवाज आपकी बिल्कुल नहीं आ रही।
ओके जी, बाकी लोगों को आवाज आ रही है?
यस सर।
यस सर।
यस सर।
यस सर।
ओके, जिनको नहीं आवाज आ रही उसके अलावा मेरे पास
जी अब आ रही है सर।
ओके, ठीक है, बीच में
आ रही है सर, क्लियर आ रही है।
ओके जी, ओके ओके ओके। अब जितनी भी हमने डेफिनेशन, अब मैं यहाँ स्लाइड पीछे नहीं ले जा सकता बिकॉज ये सब कुछ रब हो जाएगा जो कुछ मैंने यहाँ पेंसिल से लिखा हुआ है। सो यू कैन सी फ्रॉम द लास्ट स्लाइड जितनी भी हमने थर्मोडायनेमिक की डेफिनेशंस पढ़ी थी, डिफरेंट डेफिनेशंस, ऑल कैन बी एक्सप्लेन्ड विद द हेल्प ऑफ दिस डायग्राम। ये जो डायग्राम मैंने ड्रॉ किया है, थर्मोडायनेमिक्स डील्स विद हीट, वर्क एंड प्रॉपर्टीज ऑफ सिस्टम। Thermodynamics is a science of energy conversion. So here you see energy conversion processes. यहाँ पे एक, this energy is converted, work which you have supplied to the pump is converted into the fluid energy. Here and here you burn some fuel. यहाँ पे boiler में आपने क्या किया था, कोई fuel burned किया था. Here you had some fuel which was burned and this energy was converted into QB and this QB was transferred to this water. Okay, and what happened to water? Water heat energy is increased. So here you see energy conversion processes at every process. Every process is actually an energy conversion process. So that is thermodynamics. So it is a thermodynamic process. और हमने क्या पढ़ा था last slide में कि in thermodynamics we use some
एनर्जी स्टोरेज सर।
energy storage. Okay, इस केस में कोई energy storage नहीं है. But फॉर एग्जाम्पल इससे आगे यहाँ जो आप इलेक्ट्रिकल एनर्जी प्रोड्यूस कर रहे हैं, इफ इट इज नॉट बीइंग यूज्ड यू कैन स्टोर इट समवेयर इन बैटरीज और समवेयर, और व्हेन फ्यूल इज नॉट बीइंग बर्न्ड इट इज इन स्टोर्ड फॉर्म, राइट? सो हियर देयर इज नो पर्टिकुलर स्टोरेज फिनोमेना, बट इन सम अदर thermodynamic system there will be a storage system also. ओके, और हमने पढ़ा था एक लाइन हमने लास्ट स्लाइड में पढ़ी थी कि इन थर्मोडायनेमिक्स देयर इज सम वर्किंग सब्सटेंस which is either heated, cooled, compressed or expanded. यही पढ़ा था कि हर थर्मोडायनेमिक सिस्टम में there is some working substance जिसको हम या तो कूल कर रहे हैं या उसको हीट अप कर रहे हैं या उसे हम कंप्रेस कर रहे हैं या उसे एक्सपेंड कर रहे हैं. अब ये चारों प्रोसेसेस आपको इसमें नजर आ जाएंगे इस पावर प्लांट में. हियर आप पंप में क्या कर रहे हैं? यू आर डूइंग इन अ पंप, यू आर कंप्रेसिंग अ सब्सटेंस. कंप्रेसिंग. बॉइलिंग में क्या हो रहा है? यू आर हीटिंग अ सब्सटेंस. टर्बाइन में क्या हो रहा है? यू आर एक्सपेंडिंग अ सब्सटेंस. हियर इट इज एक्सपेंडिंग बिकॉज इट्स प्रेशर इज ड्रॉपिंग, वॉल्यूम इंक्रीजेस. अभी हमने वॉल्यूम के बारे में कोई बात नहीं की, वो इट विल कम लेटर ऑन, ठीक है? सो इन टर्बाइन देयर इज एक्सपेंशन ऑफ द फ्लूइड. इन कंडेंसर देयर इज कूलिंग ऑफ द फ्लूइड बिकॉज इट इज रिजेक्टिंग हीट. सो इस थर्मोडायनेमिक सिस्टम में all those four processes are occurring: compression, expansion, heating, cooling, right? इस वक्त इस सिस्टम के बताने का पर्पस सिर्फ ये था कि मैं आपको थर्मोडायनेमिक्स की डेफिनेशन समझा दूं, ठीक है? इस वक्त ये हमारा एम ये नहीं है कि आपको इस पूरे सिस्टम की समझ में आ जाए या इस ये जो पावर साइकिल हमने ड्रॉ किया है ये आपको क्लियर हो जाए. ये इस वक्त पर्पस नहीं है. दिस विल बी क्लैरिफाइड लेटर ऑन जब हम 3-4 चैप्टर्स पढ़ लेंगे और जब हम थर्मोडायनेमिक्स, ये पावर प्लांट का पूरा चैप्टर पढ़ेंगे थर्मोडायनेमिक्स 2 में, दैट विल बी क्लैरिफाइड. अब ये जो मैंने डायग्राम यहाँ ड्रॉ किए, बॉयलर, टर्बाइन, कंडेंसर और पंप की, इस डायग्राम को आई विल बी यूजिंग दिस डायग्राम इन एवरी लेक्चर नाउ to understand or to explain various thermodynamic concepts. अब जो thermodynamics की definition आपको मैंने last slide पे explain की थी, that is totally verified with the help of this practical example. So I will be using this practical example in every lecture now. Right? अब कोई क्वेश्चन है? क्योंकि अगर आपके क्वेश्चन है अभी भी, still you will have questions related to the working of this power plant. It may not be answered at this point. अदरवाइज जो हमने लास्ट स्लाइड पढ़ी थी थर्मोडायनेमिक, उससे अगर आप इसको कंपेयर करें, रिलेट करें इस पावर प्लांट को, देन इफ यू हैव एनी क्वेश्चन देन आस्क.
सर आप वो पर्पस बता रहे थे सर, वो जरा काइंडली रिपीट कर दें.
पर्पस किसका? इस पावर प्लांट के?
जी सर आप बता रहे थे.
वो तो मैं पिछले 10 मिनट से बता रहा हूँ बेटा. ओके, पर्पस क्या है? अभी जो पर्पस ये था, जो आपने लास्ट स्लाइड में थर्मोडायनेमिक्स की जितनी भी डेफिनेशंस दी थी, वो डेफिनेशंस यहाँ से फुलफिल हो रही हैं कि व्हाट इज थर्मोडायनेमिक्स? इट इज एन एनर्जी कन्वर्जन प्रोसेस एंड यू सी देयर आर एनर्जी कन्वर्जन प्रोसेसेस इन पंप, in boiler, in turbine, in condenser. Then we said that thermodynamics is what? Thermodynamics is a study which relates heat, work, and properties of system. ठीक है, thermodynamics में there is heat transfer. Here you see a heat transfer in the boiler, heat transfer in the condenser. Second thing क्या थी, thermodynamics में we deal with work transfer. So here is the work transfer, because this is not heat transfer, this is work transfer. Some shaft work is supplied. Inside a pump, what you supply? Electrical energy. Electrical energy is converted into mechanical energy, and this mechanical energy is actually given to this fluid. That's why its pressure raises. So this is work transfer. This is another work transfer, because high pressure steam, high temperature steam has transferred its work to this shaft, and this shaft is now connected to this generator, right? So that is work transfer. So thermodynamics deals with work transfers, heat transfers, and the third thing was properties of system. And throughout this system, properties are changing. For example, inside a pump, what property has changed? Pressure and volume. Volume will drop, because when you compress something, its volume drops or decreases. Similarly, in the boiler, what property has changed? Temperature. Okay. Temperature is increased. Similarly, in the turbine, temperature also drops and also pressure also drops. So thermodynamics is dealing with heat, work and properties of the system. और ये जो definition है, ये मैंने आपको इसकी help से, इस practical system की help से explain कर दी है. फिलहाल इसका purpose यही था. Okay, let's move on. ये जो system है, okay, let's move on. Now, in thermodynamics, here you see another practical example. What is this? A refrigerator, right? Just like steam power plant, which we have just seen in the previous slide, this is another system. The purpose of this system is not to produce electric power. Here, what is the purpose of this system? Is to produce cooling, right? So it also has 4 components, right? But I will not explain the working principle of this particular device. And this particular device, which is a refrigerator, its thermodynamic name, its true thermodynamic name is simple vapor compression refrigeration cycle. This is another example, practical example of thermodynamic system, but we shall learn this system in chapter 6. Because at this point of time, it is not easy to explain. The purpose here is just to tell you it is another thermodynamic system. And here again, you see there are heat transfers. There are work transfer, that is a compressor, right? There are work transfer, there are heat transfers. And there are changes in properties, -18, 3, कुछ show किए हुए, कुछ नहीं show किए हुए, ठीक है? So we will use this example because the major application of thermodynamics are 2. So major application areas in thermodynamics, those are actually 2. Number 1 is to produce power. जो हमने last slide देखी है. The purpose of the steam power plant was to produce power. That is one major application of thermodynamics, to produce power. Either it could be a steam power plant, it could be a gas power plant, it could be your automobile engine, because your automobile engine, the purpose of your automobile engine is also to produce power. So one major application of thermodynamics is to produce power. The second major application of thermodynamics is refrigeration and air conditioning, to produce cooling effect or to produce heating effect, right? So these are the 2 major applications of thermodynamics with which we as mechanical engineers are actually concerned. Thermodynamics, it's not only the mechanical engineers who are dealing with thermodynamics, chemical engineers, they are also dealing with thermodynamics, but in some other application areas in chemical industry. But for us, the 2 major application areas are to produce power in automobile engines, or to produce cooling effect or heating effect. So the working principle of this will not be explained here. We shall learn it later on in chapter 6. So currently I have just given you a brief idea about the steam power plant. So I will be using the example of steam power plant for next few weeks to understand various thermodynamic concepts. Now we will understand various thermodynamic concepts which you have already studied in your FSC or also in your metric. But now we shall try to understand or to go through those concepts again, but with the help of this practical example which I have just shown you. So here in this slide you see energy. Energy is clear. So let me draw that cycle again. With the help of that practical cycle we will learn all these concepts. So what was this? We have just learned that in a steam power plant there are four main components, starting from boiler. Then there was turbine. After turbine there was condenser, and after condenser, sorry, there was pump, right? And then it was connected to boiler. In the boiler we were supplying heat, QB. In the turbine we were extracting work, WT. What is this QB, WT? These are forms of energy. This is energy in the form of heat. This is energy in the form of work. This is energy in the form of heat. And this is another energy in the form of work. There is another energy here when you had fuel, when this fuel was burned, the chemical energy of the fuel. So all these are various types of energies. What is energy? Ability to cause changes. ठीक है, अब ये definition आप याद करें या ना करें, I will never ask such definitions in exam. ठीक है, these are meaningless. What is important? You know what is energy. You can explain energy with the help of this practical system. ठीक है, ये इस practical system की help से you can tell me what is energy. So I will never ask what is the definition of energy. I will never ask what is the conservation of energy principle. You do not need to memorize this definition. I can explain, you and me, we can explain this practical cycle or practical device. ठीक है, so what is this conservation of energy principle? अब ये जो कुछ यहाँ लिखा हुआ है इसको मैं नहीं रीड करूंगा, मैं इसे यहाँ से एक्सप्लेन कर देता हूँ सिंपल वर्ड्स में. Energy of conservation of energy principle simply means कि total amount of energy will remain constant. So आप इस पूरे system में देखें, total amount of energy which is going into this system, if this is my complete system, let me draw it. So this is my complete system. इस system में, in this system, some energy is entering, some energy is leaving. What are the energies which are entering into this system? QB plus WP. This is also entering. We are giving energy to the system plus WP. What are the energies which are leaving? One is WT, work of turbine, and Q of condenser plus QC. So the conservation of energy principle simply means the total energy which is entering into the system must be equal to the energy which is leaving the system. It means energy can only change its form from one form to another form. Energy can never be destroyed. Energy cannot be created. It cannot be destroyed. It can only change its form. So here यहाँ पे इसकी form क्या थी? Chemical energy. Here it was chemical energy which was converted into heat. This heat was converted into work somewhere. Some portion of this heat was converted into work. The remaining portion was rejected. ठीक है. So जितनी heat आपने इस पूरे system में supply की, QB plus WP. This was the energy supplied to the system. This was the energy supplied to the system. It is equal to the energy leaving the system in turbine plus condenser. So the total amount of energy remains constant. That is the conservation of energy principle. So in any thermodynamic system which you see in your surroundings, these are the phenomena which are occurring there. That total amount of energy remains conserved. During any, there could be energy loss, but energy loss doesn't mean energy destroyed. That is energy, but it is not useful energy. आप इसी system में देखें, ये जितना भी आपने QB supply किया, all of this QB is not converted into WT. Some of it is wasted. Why it is wasted, we shall learn later on. ठीक है? But total amount is same. Whatever you have supplied QB plus WP, QB, boiler energy plus pump energy is equal to the energy which is leaving the system from turbine plus the energy which is leaving the system from condenser. So total amount of energy remains constant. In every thermodynamic system, this law will hold, right? ये जो आप एग्जाम्पल है या बचपन से देखते हुए आ रहे हैं, पोटेंशियल एनर्जी 10 units, kinetic energy was 0. At this point, some of the potential energy is converted into kinetic energy. When it will be here, all of the potential energy will be converted into kinetic energy. It means the total amount of energy remains. That is the conservation of energy principle. Now, there is no need to memorize this definition, this very difficult definition. ठीक है, इसे अगर आप मेमोराइज करने की कोशिश कर रहे हैं तो आप अपनी एनर्जी वेस्ट कर रहे हैं. दिस इज नॉट द रिक्वायरमेंट. वी विल नॉट बी आस्किंग सच क्वेश्चंस इन द एग्जाम्स के राइट द डेफिनेशन ऑफ कंजर्वेशन ऑफ एनर्जी प्रिंसिपल. ठीक है, आवर क्वेश्चंस विल बी ऑफ ऑब्जेक्टिव टाइप और न्यूमेरिकल्स. न्यूमेरिकल्स अभी नहीं आएंगे, न्यूमेरिकल्स अभी स्टार्ट होंगे चैप्टर 2 से. चैप्टर 1 में इट्स थ्रू आउट अभी थ्योरेटिकल कॉन्सेप्ट्स हैं. ठीक है, ओके. नेक्स्ट द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स भी यही है जो कंजर्वेशन ऑफ एनर्जी प्रिंसिपल है. यही जो कंजर्वेशन ऑफ एनर्जी प्रिंसिपल है, दैट इज एक्चुअली द फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, दैट द टोटल अमाउंट ऑफ एनर्जी रिमेन्स कांस्टेंट. बट फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स के बहुत सारे मैथमेटिकल एक्सप्रेशंस हैं व्हिच वी विल लर्न इन चैप्टर 2. So first law of thermodynamics is just like conservation of energy. Here you see another example, total amount of energy which is going into this. Now this is the system, okay? Your body, okay? Some 5 units are going into the system, 1 unit is stored, the remaining 4 units is leaving the system. Okay? It is doing some exercise or exertion, so out of those 5 units which it has consumed, 4 units are used up. The remaining 1 unit is stored. So you can never say that out of those 5, 4 has left, the 1 is wasted. Not wasted, it is stored somewhere, right? So generated energy input, kahan se energy aa rahi hai input? From food which we eat. So greater energy input than the energy out. So greater energy input than the energy out will gain weight because the rest will be stored somewhere. So the law of conservation of energy, or first law of thermodynamics, must prevail. The total amount of energy remains conserved. It will only change its form. Right? That is the first law of thermodynamics. Second law of thermodynamics. Why we need a second law of thermodynamics when there is already a first law of thermodynamics available? So second law of thermodynamics says that energy, not only it has quality, not only it has quantity, but also quality. Look in this example. This example mein dekhe, here steam, when it was leaving the boiler, it was at very high pressure and temperature. But when it was leaving the turbine, it still has energy in it, but of low quality energy, because now its pressure and temperature is dropped. So the quality of energy is now decreased, not zero, but decreased. It is low quality energy because you cannot extract power from this steam which is leaving the turbine because its temperature has dropped. The mass, the same mass has not changed. The mass of the fluid does not leave the turbine. When it is doing work in the turbine, its mass remains conserved. So the energy due to mass is still there, but it is of low quality energy because its pressure and temperature is now dropped. So again, you increase its quality during these processes. In the condensation, in the pump, and in the boiler, you increase its quality. Another example about quantity or quality, for example, there is hot coffee, initially at 70 degrees Celsius. So what will happen? Naturally, the heat will be transferred from this high temperature to low temperature ambient. So after some time, its temperature will drop. So it means its quality has dropped, right? Because now it's a low quality fluid because temperature is very low, right? So quality, so second law of thermodynamics is just telling us that it's not only about the quantity of energy, but also about the quality of energy. एक और example मैं आपको देता हूँ. For example, the 70% of our Earth is made up of water. Okay. This water has a huge infinite mass. We don't know how much is the mass of this water. So this huge mass means huge amount of energy. the whole of this 70% of water which is available on the surface of the earth, it has a huge mass. So this mass of water, if I multiply it with, for example, here, this mass of water multiplied by specific heat of water multiplied by its temperature, mCPT. What is the units? Kilograms multiplied by specific heat of water. We will learn later on, but you already know something about specific heat, the heat which is required to increase its temperature. To raise the temperature of any substance, why? 1 degree. So the specific heat of water is about 4.2 units, kilojoules per kilogram per Kelvin. And for example, this water is available at 20 degrees Celsius. This huge 70% water is at certain temperature Kelvin. Now, what are the units of this term? MCP delta T. This Kelvin will cancel with this Kelvin. This kilogram is cancelled with this kilogram. So what is left? Energy. So it means this term is describing quantity of energy, Q, MCP delta T. And I told you that's kilojoules or joules, right? Or you may write it in BTUs. Okay? In British units, it will be BTUs. Okay. So this mass of water which is available on the surface of the earth, it is a huge amount of water, infinite amount of water. So infinite amount of M means infinite amount of Q, right? So we have an infinite amount of Q available because it has a huge M, but it is available at a very low temperature of about 20 to 25 degrees Celsius. So due to very low temperature, it has very low quality. We cannot use it to produce huge amount of work or power output. Okay. So that is one example. It's not only about the quantity, it is also about the quality. So you can increase the quality of this water by increasing its temperature and then run it through a turbine. So that is just an example that energy, it's not only about quantity but also quality. So all these concepts, first law of thermodynamics, अभी हमने next तीन chapters हैं जिसमें हमें first law of thermodynamics को in detail study करना है. Second law of thermodynamics, there is complete chapter number 6 where we will be dealing or will be discussing and doing practical problems related to second law of thermodynamics. Here is just a simple definition. And you can note that I am not very fond of reading these definitions. I will just be explaining each of these with the help of some practical examples. And I want you to just understand the concepts. There is no need to memorize anything written on this slide or on the book. If you can memorize, well, but this is not the requirement. So let's move on. Next concept is macroscopic versus microscopic. इस कॉन्सेप्ट को भी मैं उसी एग्जांपल से एक्सप्लेन करूंगा. कौन सी एग्जांपल? द सेम एग्जांपल, बॉयलर, turbine. So now you would have understood the purpose of explaining this power plant at this stage, because I will be using it throughout in the next few weeks to explain various thermodynamic concepts. Right, Ji? So this is very important concept, macroscopic versus microscopic point of view. So now we can divide thermodynamics into two main categories. One is called classical thermodynamics. Second is statistical thermodynamics, right? Classical thermodynamics is macroscopic approach. Now what is macroscopic approach? Here, for example, you see the water which was entering into the boiler, it was at 20 degrees Celsius. When it was leaving the boiler, it was at, for example, 300 degrees Celsius, right? Okay. What is this 20 degrees Celsius? It is the temperature of this water. For example, here you had, for example, 1 kilogram of water was entering into the boiler at 20 degrees Celsius. Now, what is 20 degrees? How you have measured this 20 degrees Celsius? You have measured it with the help of some thermometer. right? What this thermometer is telling you, it is telling you the temperature of this water is 20 degrees Celsius. But we know this 1 kilogram of water will have millions or billions of molecules in it. So it doesn't mean the temperature of each of those individual molecules which are present here. Millions of molecules which are present, which we cannot see from naked eye. It means this 20 degrees Celsius temperature is not the temperature of each of these molecules or particles, right? Every particle, some may have temperature of 22, some may have 18. So what this 20 is the overall average temperature of this whole volume of water. We are not concerned what is the temperature of the individual molecules or atoms which are present in that jar or at this position in the pipe. We are only concerned about this volume of water. What is the overall average temperature of this volume of water? Or what is the average pressure of this water, which is 1 bar, or 10 bar at this point. Similarly, at this point, what is 300 degrees Celsius? 300 degrees Celsius is the temperature of that steam, that volume of steam which is present at this point. What is 10 bar here? 10 bar means the pressure of that steam. But steam here doesn't mean every individual particle of steam. It is that steam, that volume of steam or certain mass of steam, which may have millions or billions of molecules. So when we are dealing in such a manner that we do not concern about the individual atoms or molecules, then this is called macroscopic approach, or this is called classical thermodynamics. ये जो thermodynamics हम study कर रहे हैं, जो book हम follow कर रहे हैं, that is classical thermodynamics. That is not microscopic thermodynamics or statistical thermodynamics. ये जो next है, एक classical thermodynamics, second is statistical thermodynamics, which is based on microscopic approach. If you want to do a master's or PhD in physics, then you may be dealing with statistical thermodynamics, in which you are dealing with individual particles, or at molecular level, you are trying to understand what is happening, how the molecules at molecular level, or how a substance at a molecular level is behaving. Then that type of study is known as microscopic level study or statistical thermodynamics. The book which we are following is classical thermodynamics. It's not statistical thermodynamics. अब मैंने आपको explain कर दिया what is meant by classical or statistical thermodynamics with the help of that example. अब ये जो यहाँ अंग्रेजी लिखी हुई है वो आप खुद पढ़ लीजिएगा, ठीक है, और उसको memorize करने की जरूरत नहीं है. I have explained you got the point, you got the concept, that is enough. ठीक है, classical versus statistical thermodynamics. So we shall be using this molecular approach in some places just for our basic understanding. But mainly we are concerned with the macroscopic level approach. Because we are not concerned what is the temperature or pressure of individual particles, right? We are only concerned about the whole volume or certain amount of size of that substance. What is the average temperature, which you can measure easily. Okay, let me erase it. For example, if I start reading what is written here, so then you will see what I have explained to you is actually written here, but in a very difficult way. What is classical thermodynamics? A macroscopic approach to the study of thermodynamics that does not require the knowledge of the behavior of individual particles at molecular level. We do not require the knowledge at molecular level. We study the gross or time average effects of the particles which may be observable. Like we can observe the temperature of this chunk of water with the help of a thermometer. So we study the gross or time averaged effects of the particles. वो जो number of particles हैं, उसका average effect हम study कर रहे हैं, which can be observable. Observable means we can measure its temperature with the help of thermometer. We can measure its pressure with the help of some pressure gauge. So this thermometer pressure gauges, they are giving you the averaged temperature of the whole volume of that substance, not the temperature or pressure of each individual particle. So that is written here. Okay? So we deal with volumes that are considerably large compared to the molecule. So whatever I have told you, it is written here in a different way, so you can understand. Okay, let's move on. Here again, the example is shown, macroscopic versus microscopic, which I have already explained to you. अब इस example में भी आप देखें क्या हो रहा है. You are heating a water, right? In this case, what we are doing, we are heating some water. So this heat is supplied Q, and water is changing its phase from liquid to gas. Now, as mechanical engineers or as a student of classical thermodynamics, we are only concerned about this Q. How much Q has to be given to this liquid so that its temperature is raised from 20 to 300 degrees Celsius. That is our requirement. We want to know how much Q should be given to this water. All of you are with me?
Yes, sir.
Yes,
Yes, sir. Yes, sir.
ओके, थैंक यू. क्योंकि अगर मुझे पता लगे कि नेट डिस्कनेक्ट हो चुका है और यहाँ मैं पिछले आधे घंटे से दीवारों से बातें कर रहा हूँ,
नहीं सर, ऐसी कोई बात नहीं.
तो थैंक्स कि आप सब हैं. ओके जी. So heat transfer. So we are concerned about this Q to raise its temperature, for example, from 20 degrees Celsius to, for example, 100 degrees Celsius. We are only concerned कि इस 20 से 100 तक ले जाने के लिए how much energy I need to supply, right? I'm not concerned कि how the individual particle is actually storing this energy. At molecular level, how this energy is transferred and how each of these molecules, their temperature is rising. हो सकता है इसका temperature अभी 98 हो, इसका 102 हो, इसका 105 हो, इसका temperature अभी 85 हो. So we don't know what is happening at molecular level. So we are not concerned with this molecular level study. That is microscopic. So we are concerned with the microscopic. But with the help of example, so you can read it by yourself. There is no need for further explanation. I have already explained everything. Application areas of thermodynamics. So in this diagram, you see the applications of thermodynamics. Wherever you see heat and work interaction, wherever there is energy conversion, that is actually thermodynamics. But during that energy conversion, if there is some heat involved, a thermal part involved, then it becomes a pure thermodynamics. Otherwise, if there is no thermal part involved, only the other forms of energies, so it could be electrical application, it could be fluid mechanics application, because energy, it's not only thermodynamics or mechanical engineers which are dealing with energies. The other branches of engineering are also dealing with energy, but they are not dealing with thermal part. So in all these applications which you see in your surroundings, those are actually the application of thermodynamics. So from this, you can understand the importance of this course, thermodynamics, because if you have a good solid foundation of this course, then you can design an air conditioning system. You can design these jet engines, because inside a jet engine, there is also the fuel which is getting burnt, and that energy of the fuel is actually converted into the high velocity of the gases which are leaving this engine. And that's why it is moving in particular direction. So jet engine, refrigerator, power plants, जो हमने अभी डिटेल में स्टडी किया, car radiator, all these are thermodynamic applications. Now there is a human body. Why human body is also a thermodynamic system? Because, for example, you want to design an air conditioning system. So to design an air conditioning system for a room or for a building, you need to know how many people will be sitting there, because all of us are emitting energy in the form of heat. Our body is continuously, because our body is continuously emitting energy in the form of heat. And which heat? It is the radiant energy. We are radiating energy in our environment, right? Because our body wants to keep its temperature at 37 degrees Celsius. So if the outside temperature is low, so it is losing energy. And when you will study radiation heat transfer in the subject of heat transfer, you will know that every object whose temperature is above 0 Kelvin is actually radiating energy, because everything is made up of molecules. Molecules are continuously moving or vibrating. So during this molecular motion, electrons are continuously shifting their cells, and during this shifting they emit radiation, electromagnetic waves. So the number of people which are present in one particular room will affect the air conditioning, because if an air conditioning system is designed for 10 people, but if in that room there are 100 people, then your air conditioning system will not be able to cool that space. So that's why the presence of human being has to be taken into account when you are designing an air conditioning system. So that's why human body is also considered as one application area of thermodynamics. Here you see another typical example of energy conversion. Here you are converting the radiant energy of the sun into heat in this device, which is called a solar collector. And then this heat is transferred to this storage tank, hot water tank, and then it is transferred to the household for various domestic applications. So here you see the energy of the sun is converted into heat with the help of this device, which is called solar collector. So there is energy conversion process, and there is thermal part involved. That's why it is thermodynamics. So all these are application areas of thermodynamics. Okay, जी, how much time is left? कब तक है ये क्लास?
सर 15 मिनट रहते हैं
3:40 तक 15 मिनट्स रिमेनिंग
यस सर, बस 5 मिनट और
3:40 तक.
सर 15 मिनट रिमेनिंग
3:40 तक है.
Okay, जी. So this was about the application areas of thermodynamics. Now the next concept is a system surroundings. ये भी आपने अपनी FSC की physics में पढ़ा हुआ है, या maybe आपने engineering physics में भी पढ़ा होगा. Now I will not read these definitions. I will explain these systems with the help of the same example. So let me draw that example again. Boiler, turbine, condenser, pump. This is, for example, a thermodynamic system. Q, here we are extracting work. W, here we are rejecting heat. QC, here we are giving work in the pump. WB. So this is a thermodynamic system. Now what is written? A quantity of matter or region in space chosen for study. For example, I choose only boiler. This is my thermodynamic system. Okay. So this is the boundary I have drawn about. I want to study only boiler, right? So inside this boundary is your system, and everything outside this boundary is your surroundings. This is surrounding, this is your system inside this boundary. Okay. Surrounding say what is entering into this system. This heat is entering from surrounding into the system. This fluid is entering from the surroundings into, because system is this one. I have drawn a boundary like this one. So in this system, from the surroundings, what is entering or leaving? Heat is entering, some fluid is entering from this side, and fluid is leaving from this side, right? So if I choose a different system boundary, I can draw a system boundary around turbine also. Now, when I chose that boundary, I can write its equation. We will learn how to write the equation of this system boundary, because the energy in, because here your fluid is entering with some energy in it. Already it has some energy in it, E1. और इसी में ये energy add हुई Q, and now it is leaving at some energy E2. So I can write its equation from first law of thermodynamics, or the conservation of energy principle says that energy entering Q plus E1 must be equal to E2. So this equation is only for this system. Similarly, I can write another equation For this system, this is new system. For this system, everything outside is surroundings. I can draw a system like this one. If I choose that as my system. Now for this system, what are the energies entering and leaving? For this system, WP is entering इस पूरे system में. Secondly, QB is entering. This is QB plus QB is equal to this WT is leaving plus this QC is leaving. Now you see, when I chose that, okay, when I choose this as my system, then the equation was this one. When I choose that boundary as my system, inside this boundary is my system, outside, everything outside is surroundings, then the equation is like this, right? So we can write such equations for any system. Now we have to select a system properly. Whenever we will be solving questions in chapter 2 and so on, we shall be selecting an appropriate system. So now it is clear what is system, a quantity of matter. ये जो system है इस boundary के inside, whatever you have chosen is your system. A quantity of matter or a region, ये जो region हमने select किया in space chosen for study is called system. अगर ये मैं system boundary ऐसे भी बना सकता हूँ. If I want to solve turbine and condenser combinedly, so I can combine turbine and condenser and I can draw another system boundary only across turbine and condenser. Then I can write a new equation for this new system. So depending upon our requirement, we shall write a proper equation and then we shall solve these equations later on to find out some unknowns. So ये हम chapter 2, 3, 4 में आगे करेंगे. But for the timing, you should know what is meant by system. So system, so मैंने आपको with the help of that example, I told you what is system. ठीक है, आप अभी तक system और boundary सिर्फ इसी तरह देखते आ रहे हैं अपनी books में, text books में, इससे पहले 9th, 10th में. So I told you I will clarify all of your basic concepts again. So now you do not need to memorize this definition. ठीक, ये आ गया, पढ़ते जाएं. जो कुछ यहाँ लिखा हुआ है ये मैंने यहाँ explain कर दिया. For example, let's read it. In study of thermodynamics, we choose a small part of the universe. We choose a small part of the universe to which we will apply the laws of thermodynamics. ये मैंने इसके ऊपर apply किया. Law of thermodynamics. कौन सा? First law of thermodynamics. We call this subset a system. We call this subset जो हमने choose किया a system. Clear? Similarly, you can define the system in a different way. System is a macroscopically identifiable collection of matter. Macroscopically identifiable collection of matter. देखिए कितनी मुश्किल definition है. But there is no need, I'm again telling you, there is no need to memorize these sentences. Now you are clear what is system. Surroundings, everything outside the system. Surrounding is must, because surrounding से ही तो QB आ रहा है. Surrounding से ही E1 in हो रहा है system में. Surrounding में ही E2 जा रहा है. So it's not like a system is a very important thing. Surrounding is useless. Both system and surroundings are very important, because inside your system is always interacting with the surroundings. ये जो आपका system था, that is also interacting with your surroundings. But how? With these energies, WT, QC, WP, and QP. For this system, it was also interacting with the surroundings, but in what manner? In this manner, E1, E2, and QP. So the mass or region outside the system is called surroundings. ठीक? Boundary is clear. We draw a boundary. ठीक है? Or this boundary could be a real boundary. You may say कि ये जो boiler का outside shell है, that is my boundary. Or you draw an imaginary surface. ये हमने एक imaginary surface draw की थी ना. So the boundary can be real or imaginary, right? और purpose क्या है boundary का? To separate the system, to separate this system from the surroundings. So all these definitions which you have already learned, but now I think you have a better idea what is meant by system, surroundings, and boundary. Okay, I stop here. We have already covered quite a lot. So we shall meet again in the next class. So
एक्सक्यूज मी सर
जी जी
सर आज तो ग्रुप 1 की क्लास थी सर, तो कल
जी
ग्रुप
जी
2 की